Okay, welcome back. So today we're going to do an example, and in this example we're going to use those 7 steps for graphing rational functions. Okay, so we're going to use this function and we're going to graph it on this graph here. And so the first thing we're going to do is we want to find the vertical asymptotes. Okay, so step 1. Okay, we're going to find the vertical asymptote, so we're going to have to solve this equal to 0. Okay, so we want to set x squared, 2x squared plus 5x minus 3 is equal to 0. So we're going to factor this. And so we find that the factor, this factored gives us 2x minus 1 and x plus 3 equal to 0. Okay, so we solved this before, and so this tells us we're going to have vertical asymptotes at x equal to negative 3. Let me just make sure I wrote that down right. Yes. And the other vertical asymptote is going to be at x equals 1/2. Okay, so we know we're going to have vertical asymptotes there, so why don't we graph those now. So the vertical asymptote x equals negative 3. So we're going to have a vertical asymptote here. Okay. We're also going to have a vertical asymptote at x equals 1/2, which is going to be right about here. Okay. So we've got 2 vertical asymptotes that we've already got plotted. And so now we want to find out whether we have horizontal or oblique asymptotes. Well, since the degree of the top is less than the degree of the bottom, there are no oblique asymptotes. We don't have to worry about oblique asymptotes, but there is a horizontal asymptote at y equals 0. So we know we have a horizontal asymptote at y equals 0. So let's plot that. Okay, so we have 1 here. Okay, so far so good. So now notice that we've got quadrants here that we're going to have to pick a test point. So we've got a domain here, we've got this area, this interval here, we've got this interval here. So we're going to have to figure out eventually what's going on with the graph, because it could be here, 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 or here. Okay, so now let's talk about x and y intercepts. Okay, so the y-intercept. So to find the y-intercept, well, if we plug 0 in here, we don't get 0, so we're good. So let's find out where the y-intercept is by plugging in 0 for x. Well, if we plug in 0 for x, everything goes away except the 1 and the negative 3. So that tells me that we're going to have a y-intercept, okay, at 0, comma, negative 1/3. Okay, so that's going to happen right about here. So 0, negative 1/3 is right about here. Okay, and so now we've got that plotted. Now the x-intercepts. Let's see if there are any x-intercepts. Okay, well, to find x-intercepts, we're going to set the numerator equal to 0. So x plus 1 equal to 0 means that there is an x-intercept at x equal to negative 1. So it's going to be at negative 1, comma 0. So let's plot that one. So negative 1, comma 0. So there's going to be an x-intercept. Now notice that right here, we already know it's going to cross the horizontal asymptote, which is going to be the next step. Where does it cross? So we know that it crosses here. Okay. But let's go through the steps anyway, just to show you that it works. Okay. So now in step 5, we want to know, hey, Does the graph cross the horizontal asymptote, any non-vertical asymptote? So the only non-vertical asymptote we have here is the horizontal one. Now we already know that it crosses here, but let's show you that the technique works. So if I didn't know that, then what I would do is I would take the function and set it equal to the value of the non-vertical asymptote, in this case 0. So I would set this equal to 0, right? Well, the only way this is going to be equal to 0 is when this is equal to 0. So again, it's all the same thing. So we're going to end up solving x plus 1 equal to 0, right? And then we get the same answer. We find out that it's at x equals negative 1, okay? Which is exactly what we got before. So now what? Now we want to find test points. And step number 6 is where we're going to pick our test points. Okay? So now what I'm going to do is I'm going to draw a table. Okay? So let's draw the table. Okay? And so I'm going to draw the table so we can find our intervals and find out whether we're above or below the x-axis and stuff. Okay? So, here's our interval. So our intervals, we've got one interval is from negative infinity to negative 3. Okay? We've got another interval from negative 3 to, how do I want to do this? To negative, or to 1/3, or hold on a second. Negative 3 to 1. Yeah, negative 3 to 1 because we have the x-intercept here. So that's going to partition our graph because it's doing, we don't know what it's doing at the interval. Remember from previous videos, we have to test also here. Is it bouncing? Is it crossing? What's going on? Okay, so we're going to go from negative 3 to negative 1. And then we're going to go negative 1 to 1/2. So that's going to go from here to this asymptote. And then the final one is going to go from, let me erase this. And the final one is going to go from 1/2 to positive infinity. Okay, so now we're going to figure out our test point. Okay, now from here, we just pick the ones that are going to be the easiest. So again, here I would just pick negative 4, right? And then here, the obvious one would be negative 2. And then of course, the obvious one here would be 0. And the obvious one here would be 1. And so we're going to use these as test points. And what we're going to do is we're going to plug these test points into our function to see whether we get positive or negative values. Okay, and then we're going to plot those points to help us graph. Okay, so here, if we plug in negative 4, what do we get? We get negative 3 on top. Okay, so we get negative 3, and then over here we get what? When we plug in negative 4, we get negative 4, we get negative 8, negative 9, so we get negative 9, right? Yeah, negative 4 times 2 is 8, negative 9, and then negative 4 plus 3 is negative 1. And so we get positive 9. So f of x, we get what? We get a negative 3/9, or a negative 1/3. Okay. Now, what if we put a negative 2? So negative 2, well, negative 2, we're going to get a negative 1 on top. Right? We get negative 1 on top, but again, if we put a negative 2 here, we get negative 4 minus 1 is negative 5. So this becomes a negative 5. And this becomes a positive 1. And so we get negative 5. So we get negative 1 over negative 5, which gives us a 1/5. Now 0 is easy. If we plug in 0, we get 1 on top, and we get negative 3 on the bottom. Okay, so that one we got negative 1/3. That's our y-intercept. And then if we plug in 1, we get 2 on the top. And here if we plug in 1, we get 2 minus 1, which is 1. And here we get 1 plus 3 is 4, so we get 4. So we get 2/4, so we get 1/2. Okay? Now, where are we at with the x-axis? Okay, well here we're going to be below the x-axis. Here we're going to be above, and then we're going to be below, and then we're going to be above. Right? Negative, positive, negative, positive. Okay? So now we're going to plot. And so in this case here, we've got negative 4 and negative 1/3. So negative 4 and negative 1/3. So we're right here. And we're below the x-axis. Here, we're at negative 2 and 1/5. So negative 2 and 1/5 is right here. So we're saying we're going to be right about here. Oh, positive. It's positive 1/5. So I'm above, right there. Okay? And what else? Negative 1, oh, 0 1/3, okay, we got that one. And then 1 and 1/2. 1 and 1/2 is right about here. So I'm over there. So notice where these points line up. So here this point is in this quadrant. Okay? And here it crosses here. So we're not sure what's going on over here, but over here it's over here. It doesn't cross over here. So we know we're doing something probably like this here and like this here. Okay, but again, let's ask ourselves what's happening as we get closer to the asymptotes. So as we get closer to negative 3, right, what's happening as we get close to negative 3? Well, if we know we're over here, below, right, we're negative, but as we get closer to negative 3, this is going to go to negative infinity. Okay, so this will go from here, we know it's going to go to 0, so this is going to go like this. Okay, and then over here, as we get closer to a half, same thing's happening. As we get closer to a half, this is going to go off to positive infinity, and this is going to go closer and closer to 0. Okay? Now, what's happening here? As we get closer to negative 3 on the right side, okay? Well, we know this thing is getting closer and closer to 0, but is it going negative or positive? Well, let's find out. So as we get closer to negative 3 on the right side, so let's say something that's larger than negative 3, okay, so if we have negative 3, so here, if we have something that's close to negative 3 but on the right side, larger, well, this is going to end up being, let's say, negative, let's say negative 2.5, right? Negative 2.5 is going to be positive here, and negative 2.5 is going to also be negative here. Okay, does everybody see that? So here, this is going to be positive, right? Because if this is negative 2.5, that plus 3, that's going to be positive. Here, negative 2.5 times 2 is still negative, minus another one, so this will be negative. But as this is getting smaller, right? This is going to a number. This is going to get smaller and smaller and smaller, which means this thing is going to 0, but it's negative. So this is going off. This is going to negative. Hold on a second. No. This is negative, but yes, but this is negative. So this is going to positive infinity. So this is doing something like that. And now if we get closer to a half, this, as we get closer to the half on the left, this is getting closer and closer to 0. But this is positive, okay? This is positive, so this, but this is, hold on a second here. Oh, this is negative. So we're less than a half. Right, so if this is a half, this is 1, so if this is less than a half, yeah, so this will be negative, and this will be positive, and so what's going to happen is this is going towards negative infinity, so this is doing something like that. And that's the end of the sketch. So notice how we use the table to help us plot these and see what's going on. So notice that the asymptotes also helped us, but we have to make sure that we ask ourselves, okay, what's happening to the graph as you get closer and closer to these asymptotes, the vertical asymptotes? Because in some cases it could have done like this, but it didn't because there would have been another x-intercept. Okay, and since it only crosses here one time, it makes sense that it's going to go off to positive infinity this direction and then negative infinity in this direction. And that's the final answer. Okay, so again, make sure you've worked through these on your own, and if you have any questions, please ask. Okay, take care, have a great day.